Yes, hello. I'm going to work on 10.4 now. I think I'm sharing the screen. I hope you can see this. Still would like a better color. It won't let me. Why do I not get to save that as a color? Okay. So you need to know that to add radicals, you need both. This is important. The same index and same radicand thing under the root. So this is like combining like terms. For example, 5a plus 8a is 13a. You see, like terms. 6x squared plus 5x minus 3x squared. You combine the 6x squared and the 3x squared, you wouldn't combine it with the x, with the 5x, I mean. So you see, from here to here, this is basics, chapter 5. So when you're talking about radicals, 3 square root of 2a, let's say, plus 5 square root of 2a. This is where you have to look at this the same. Here with the 5a and the 8a, I say $5 plus $8 is $13. $6 minus $3 is $3. 3 apples plus 5 apples is 8, still apples. Okay? Stuff only changes when you multiply. Still apples. So then we're going to apply this over here. So you would look at this first and say, I'm supposed to be adding, but they're not like terms. You need like terms. So what happens is as you simplify and use what you learned in previous sections, things will fall into place and you will see that they become like terms. So let's look at this one. The 6 is just a 6. But you could rewrite the thing under the root as 5 times x squared times x, because your goal is still to simplify that term, and you want exponents that match your index, and your index in this case is a 2. And then you write plus 9x, and then we're going to try to simplify that 45. Okay, 45. 5 times 15, or silly, 5 times 9. And then a 9 is a 3 times 3, or however you want to take that 45 apart. So we have the 45. I'm going to stay under the root for now and rewrite it with exponents that match my index if possible. So it's a 3 squared, which is a 9 times the 5. And then you have that x in the original there. Then you get out from under there what needs to come out. So there's a 6, the x comes out, this x here, right? This is the one that has an exponent of 2. The rest of it has to stay under. And then we have a 9 x times what comes out. And some of you will do this. Go ahead and simplify all at once. Sorry, this is a little messy. 3 comes out, what stays under? 5x. Then you have, nothing else happens with that left term, plus 9 times 3 is 27. And now you have like terms. What's the like term about it? This is the like term. 6 apples plus 27 apples. You see? X squared of 5x, x squared of 5x, same index, same radicand, same variable, like the x on the outside already, So we have how many apples? 33 apples. So hopefully that helps. Usually students like this section fairly well, as long as you can do 10, 1, and 2. Why can't I get scrolling? Hang on, sorry. Whoa. Clear all drawings. Okay, do I want to do this one as well? It's just like the last one. You create underneath items that have an exponent that matches the index and then simplify. I'm gonna let you do this one because it's so very similar. Oh. Add. And like we'll meet in class on Zoom or whatever. So we're supposed to add. Okay, now we're dealing with fractions. So there's a bunch of stuff thrown together. Now you have radicals and fractions, and you're supposed to add them too. So when we add, we need a greatest common denominator, right? A over B plus C over B is A plus C over B. Still basic math applies always. So you need an LCD between 2 and 3. It's super obvious. So we're going to say that's a 6. If for us to add them, we have to first make the common denominator. Okay, and then you ask, what did you do to the 2 to make it 6? 3 times 2 is 6. So whatever you do downstairs, you do upstairs. So, and none of that has a radical right now, except that square root of 7. So don't confuse things. 3 times 9 is 27. And then on the right one, we're going to say, what did I do from 3 to 6 times 2? Whatever I do here, I do here. Now be careful, this 2 isn't under the radical. This 2 is outside. So the 7 out here and the 2, 7 times 2 makes 14. Then you're allowed to, I'm showing many steps, but that's okay. All over 6, right, using basic math. And then you have 27 apples plus 14 apples, 41 apples. Now, 27, okay. So sometimes I can simplify this. You should always at that point ask, can you simplify this? Like, what if the 41 and the 6 had something in common, you know, but there's no 2 in there and no 3 in there. So this is the end of the story. And a 6 under a radical and 6 outside the radical do not simplify, okay? They're very different. Put it in a decimal form and see what a square root of 6 is. It's very different. Okay, so, oh, I'm trying. Let's clear. Add, assume that all variables represent positive real numbers, and that just means, again, that we're not going to worry about whether we have to pull an absolute value or whatever, because we're just going to assume they're positive, so we're not going to have to worry about an imaginary number here. Okay, so let's see, I have no clue. I have not looked at this yet. But the first thing I'm going to look at is I'm adding, and I have some radicals involved, and maybe I need to leave that one alone for now. And I need to simplify this one. So this depends on the problem, but you could use the quotient rule. And a square root of 16 is 4. So I'm going to do that first because I don't want to fiddle with a radical in the denominator, okay? So square root of 16 is 4. And now you got to create a common denominator. Oh, I'm sorry. What happened? I hit the wrong button. Just a second. To bring my picture back. Oh, this one's a little bit longer, isn't it? I'm going to skip some of these. Here it is. maybe I need to go faster. I just try to give you a chance to take notes as well. So, but you can always pause, right? Now I need a common denominator. Between 8 and 4, hopefully it's an 8. So I'm gonna leave that one alone again. And then this one here times 2 times 2. Now be careful, this 2 is not under the root. This 2 is on the outside of the root. So square root of 2x times 2 is 2 square root of 2x. And then a denominator is an 8. Now, I should have gone ahead and worked the square root of 18x, just a second. Oh, terrible today. Let's simplify this because we can. Square root of 18x, square root of 18 is 2 times 9. Square root of 2 times 3 squared times x, right? And then do you see how the 3 comes out and the 2x stays under? Okay. So I should have done that already. And now I have a common denominator. I can go across. All over 8. And then I can say, okay, 3 apples plus 2 apples is 5 apples. And why do I do that thing with the apples and the dollars? So that I don't accidentally multiply underneath or make this something that it isn't. This is simply you're combining like terms. 3 apples plus 5 apples, or 2 apples is 5 apples. Not accidentally make them x squareds or something. That happens when you're multiplying. This is why I do that a lot. Try to make it less confusing. Not always successful. And I'm talking at the same time that I'm writing and I'm pushing buttons, and yeah, it's not always easy. Okay, add or subtract. Let's see. The first thing you should probably do is see if you can simplify each one. The 3 is just a 3. Square root, I can make this something squared. How about a y cubed, right? 3 times 2 is 6, plus 9. Oh, this is interesting. And sometimes I don't notice it until I already work on it. You see how those are really like terms. I could have gone in and put them together and then simplified. It just depends on, you can simplify the individual terms first, or you can combine them first and then simplify. I'm not saying my way's better, but since I went this route, I'm gonna go ahead and stick with it. The 2 matches my index, y cubed. The 2 matches my index, so y cubed. And then you have 3 plus 6 is 9. And then you have borrow $1 and deposit $9, so you have $8. So I don't always like the way I approach something. First thing, sometimes I might in the future say, oh, I have negative $1 plus $9 and come over here and make that $8. And then you have the 3 and the 6, so 9 plus. And then you can say, now I'm going to simplify that piece and make that a y cubed. So anyway, it's different, not wrong. Add or subtract. You see, this time, the reason I probably did the last one the way I did, I simplify each one first, is because most of the time they're not like terms. Do you see how none of these are like? None of these are like, so you have to simplify them first. So we're going to take the 9. Oh, I don't feel like doing this one right now. You have a calculator, but I'm committed. 175. Divisible by 5. I'm having a moment. I'm going to pause. Get over myself. Okay, so one of the things I like to take pride in is that I'm a human being and I have my moments. I'm blonde, I'm doing several things at once, and this isn't my first. I've been on this for 3.5 hours and I'm just starting to have trouble. Anyway, 5 times 35 is 175, and then you have a 5 times a 7. So we could write that as a 5 squared times 7 minus, now we're going to deal with the next one, 3. Square root of 8 is 8 is 2 squared times 2. 4 times 2 is 8. True. Wonder if much will happen with this one. 63. 3 and 21. I can do that much, right? 3 and 7. So this is 3 squared times 7. Okay, then we keep going. 9 times 5 comes out, 7 stays under. 3 times 2 comes out, 2 stays under. 3 times, whoops, uh-oh, wait. Oh, 3 times 3 comes out, 7 stays under. Now you have 9 times 5, 45. 6, 9, and then you say, well, which ones are like terms? You have $45 minus $9 is $36 minus 6 tomatoes, and then they don't combine. And gosh, if I made a mistake, catch me if I'm wrong, bring it to class, and I'll give you extra credit, because I have my moments right now. I probably shouldn't be doing this anymore until tomorrow or later. But I kind of like to get this done. You might also want it in 2 sections. Let me see what time it is as far as, how many more do we have? I don't have to do them all. 7, 8, 9, okay, 10, then we're going to multiply still. I should probably at least get the adding done, and then we'll do the multiply another day. So I have 2 more. Okay. This one here, I could be using, this is really 10-3, isn't it? Most of it, simplifying the individual pieces. Okay. A to the 5th. 5 squared A, B squared B. Stay under the radical. 5 squared. Now, I'm going to split the A to the 11th into something evenly divisible and close as I can to the 11. A to the 10th times A is A to the 11th true. And I'm going to go ahead and do the B squared B thing, because I was already there. I'm going to have an intermediate step for one of them. 64. 64 is 32 times 2, and 32 is 2 to the 5th. So this is 2 to the 6th power. I'm trying to, do you see how this is 2 to the 6th power? But if you do it that way, you need an exponent of 2, so you're going to end up having a 2 cubed. 3 times 2 is 6, and then that's really an 8. You see what I'm saying? So I'm going to make 64 just an 8 squared instead of a 2 to the 6th power, because it's just easier. It's not wrong if you do it the other way. Oh, and those 2 are like terms now that I'm looking. No, they're not. They're not. The A's and B's are, but everything in the radicand would have to be the same, so they're not the like terms. Square B. Oh, Lordy. I'm going to go ahead and put another step in. I know this is the same, okay, so bear with me. I would have done this a little differently if I didn't have a moment today, but I want my exponents to match. A to the 5th, 5 times 2 is 10. And that's the only reason I had to do this again. So I'm going to pull them all at the same time. I need something to the 10th, so it's a to the 5th. I need a 2 there on the outside, and I got it. So not my best work again. It's coronavirus, you know? So give me a break too, right? Everybody else gets a break. How about I get a break for not being so perfect this semester? Pull the 5. And then here, be careful, that 5 almost looks like an index. It's the exponent. This is a regular square root. Okay, so we have I'm gonna pull the 5 to the front. The 5 comes out, and then the a to the 5th from the front, the a stays under, the b squared comes, the b comes out. See, and this is why I often use a little parenthesis so I don't make this mistake. Hang on, for some reason, I must be in the drawing section because I cannot seem, whoops, I cannot seem to erase this thing. Okay, I'm trying to go back to annotate. So, yeah. This b is in a parentheses, you see, something to this power. So the b is the only thing. The 5 comes out, the b comes out, and then what stays under? The plane A and the plane B. What comes out? 5 comes out, a to the 5th comes out, and the b has an exponent of 2 and it comes out, right? So if we're going to look at that way, be careful. This is tedious. Square root AB. The 8 comes out. The a to the 5th comes out, and the b comes out. What stays under? AB. So this is a little odd because can you see how now they're all looking like terms? This here is the same variable, same exponent. I see a to the 5th b square root of a b. Oops. Maybe I do need to record this over. I just don't feel like it. So let me be human. Once in a while, you guys get to be human. I get to be human. But do we see how those are like terms? So you have 5 tomatoes minus 5 tomatoes is 0 tomatoes plus 8 tomatoes is 8 tomatoes. The reason this one is interesting is that you would think, hey, why can't I just do that in the beginning? But these, the way they're written, are not like terms. And then even when I come here, you know, because that a to the 5th is on the outside, that's why that was not very obvious that they're going to be like terms. So you have to be careful. They're not always going to be like terms. Sometimes 2 out of the 3 are like, but in this case, they're all like. Okay, can be confusing, and you also have to be careful. When you write it, I'm trying to scroll. Oops, there it is. Add, I'm gonna let you manage this one. The first thing you probably wanna do is this quotient rule, meaning you're gonna split up the root on the top and bottom. And then do you see how on the bottom one, the x comes out, and on the bottom on the right, the 3x comes out. And then you have to create common denominator. We've done this already. I'm gonna let you handle it. And then we're gonna find the perimeter here, and then we're gonna call this good. We did the adding and subtracting of the, actually, I'm just gonna start this one and then let you handle it because you already know how to simplify these radicals. They're all the same, you know, at some point. But perimeter means, you know, going around the outside and adding them all up. So you have a 2 square root of 3 plus 3 square root of 27. And I guess I started on the left and working my way around, plus square root of 27 plus 5 square root of 75. Oh, might as well work it now. 2 square root of 3 plus 3 square root of 27. 27 is 9 times 3, so 3 squared times 3 plus square root of 27. 3 squared times 3 is underneath, plus 5. Square root of 75. 75 is 3/4. So this is 5 squared times 3, 25 times 3. Then what comes out, what stays under? This 3 is that 3, so be careful here. This 3 comes out. This 3 stays under, you see? Plus this 3 comes out, and this one stays under. This 5 comes, okay, this 5 stays, this 5 comes out. What stays under? The 3. Then 2 square root of 3 plus 9 square root of 3, because 3 times 3 is 9, plus 3 square root of 3 plus 25 square root of 3. My eyes are starting to feel it. So you have 2 apples plus 9 apples is 11 apples, plus 3 apples is 14 apples, plus 25 apples is 39 apples, I hope. And then it's in inches. Yep. Okay, so, and then I'll start the second 10-4 section for multiplying. Okay, thank you. Sorry, that was pretty rough. I think I'll record that another day.